We expect our phones to buzz before the rain even starts. This modern radar dome represents an entire infrastructure dedicated to predicting the weather down to the minute. These instruments bounce microwave pulses into the atmosphere, detecting the slightest shifts in moisture and wind speed long before a storm system reaches city limits. That raw data is processed in seconds, triggering automated alerts that hit our screens and broadcast networks, telling us exactly when and where to seek shelter. Because of this constant surveillance, severe weather rarely catches a community completely off guard today. We know what is approaching, and we know its exact arrival time. Yet that expectation of safety relies entirely on an invisible network of digital technology. Take the machines away, and we are just as blind to the sky as we were a century ago. In the spring of 1936, none of this infrastructure existed. There were no digital models, no emergency broadcast systems, and no continuous radar loops. Weather forecasting was a slow, manual process. Meteorologists relied on telegraphs and handwritten charts, piecing together atmospheric conditions from isolated reports that were often hours out of date. Instead of pinpointing a specific cell moving over a specific county, they could only identify broad areas of low pressure sweeping across entire states. Because the data often traveled slower than the storm systems themselves, warning a localized community about a rapidly developing severe event was practically impossible. Without institutional warnings, ordinary families were their own meteorologists. Their only defense mechanism was to step outside and observe the sky themselves. They watched for sudden drops in temperature, the rapid buildup of dark clouds on the horizon, or the physical rumble of thunder in the distance. When human senses are the only early warning system available, entire communities are left structurally exposed to sudden, violent shifts in the weather. That exposure would prove lethal on April 5th. High above the Deep South, highly volatile atmospheric conditions were taking shape across the region. Looking at this map, the first component began over the Gulf of Mexico. Warm, humid air surged rapidly northward. Simultaneously, a cooler air mass advanced from a different direction, cutting directly across that humid Gulf air. When opposing temperatures collide head-on, the denser cold air acts like a wedge. It aggressively forces the lighter, warm air upward into higher altitudes. Once rising, powerful crosswinds catch the warm air, twisting the updraft into a rapidly rotating column. Extreme upward lift, heavy atmospheric moisture, and severe wind shear. This specific combination is the exact mechanism required to generate violent, widespread tornadoes. The atmosphere was actively assembling a devastating storm system. Yet, because the friction was happening thousands of feet up, it remained entirely invisible to the people below. To a meteorologist sitting at a terminal today, the danger of that severe instability would be obvious hours in advance. The data would clearly mandate an immediate warning. But the residents of Tupelo, Mississippi lacked this top-down perspective. They had absolutely no way to measure the catastrophic wind shear occurring out of sight. When they looked up that afternoon, they saw heavy, swirling overcast. It was an ominous sky, but incredibly common for a southern spring. To the naked eye, it simply looked like a heavy rainstorm was rolling in. People noted the dark clouds, expected a wet afternoon, and felt no reason to panic. The danger of this specific storm structure is how quickly it transitions. A rotating column can breach the cloud base and drop to the earth in a matter of minutes. Oblivious to the physics playing out above them, the people of Tupelo went about their Sunday routines, totally unaware that the atmospheric trap had already been set. The devastation that followed was compounded by the fact that the sky offered no true warning. The storm hid a predictable meteorological event behind the disguise of a typical rainy day.